Welcome to this installation of the Esri Emergency Call Taking and Dispatch webinar series. My name is Mike King and I manage our global effort in call taking. Today's topic will be 3D GIS for improved event response. Our goal, quite simply, is to provide content that benefits you and those in the call taking industry, and the efforts that are going on to understand and prepare for and then implement location accuracy, indoor routing, next generation 911, which all includes 3D. We recognize that many of you are in positions of influence in your organization, and your thought leadership is driving change. We really want to acknowledge your contribution to the next generation 911 movement and hope that you find this information to be useful. I'm joined by a few of my Esri colleagues. For this webinar, Ray Umali will be managing the webinar. I also have with me Britt Bromley, who is our Public Safety Partner Manager. Britt and I work very closely on the movement and direction that the call-taking industry takes at Esri, including our interactions with many of the CAD and 911 or records management providers that you lean upon. Please enter any questions that you might have in the chat window. And with that said, let's jump into our agenda and we'll get this call started. And we think the call will actually go fairly quickly today and give you a little time back. The first part of the presentation will be delivered by Esri's Bo Reich and Ian Feathers, who will cover some of the work that's being done to create 3D solutions that will assist you in your everyday operations. You might be interested to know that Esri will continue to work, as I said, with the major CAD and RMS providers who incorporate this functionality into their core solutions, but the efforts that you are making will speed up this migration and ensure that you're relying upon the most up-to-date and authoritative address data information available. We'll, once we hear from Bo and Ian, we'll then hear from former Esri Startup Partner Program Manager Miles Sutherland, who now owns two exciting companies that we are proud to partner with, GroundView and IndoorVU. They are expert in creating 3D content in both pre-planning and in exigent circumstances. So thanks again for joining the webinar, and please consider forwarding this recording, which you should receive the link to in a few days, to your colleagues. With that said, thanks again, and let's turn the time over to Bo, Ian, and Miles.
Thanks, Mike. And as Mike noted, we recognize that you all are thought leaders in your space. So we'd like to take a second to introduce our new ArcGIS Indoors product that's currently in beta. Our team supports the evolution of safe, sustainable, and productive workplaces and public venues. For this webinar, we'd like to focus specifically on how we can help maintain a safe and secure space for people to live and work. That's really important because ArcGIS Indoors plays a critical role in this. We spend about 90% of our time indoors. So we need a system capable of creating, curating, and sharing indoor location information. So let's talk about some of the people that it takes to maintain a safe and secure workplace or venue. First and foremost, we have our business owners. Every day, people enter their facilities with the expectation that they'll go home to their loved ones at the end of the day. So business owners need a system that not only delivers insight into how long-term strategic decisions impact the safety and security of those occupants, but also delivers rapid situational awareness to train first responders in the event of an emergency. In the event of emergency, they need to guarantee first responders have the most up-to-date information that helps them understand where the event occurred, how to get there, who is affected, and any other environmental conditions that might need to be considered. Next, we have operators. Responsible for a number of business operations that influence workplace safety, employees in these business units need to work both in the office and in the field to maintain up-to-date records of data such as employee information, security features, and environmental conditions. Maintaining up-to-date records of this type of information allows for first responders to quickly assess and effectively mitigate emergency situations. Imagine the situation. An administrator marks an emergency event in the third floor office. This notifies operators on the HR team to quickly access records of nearby employees that are affected. The environmental health and safety team collects sensor data on room temperatures, carbon monoxide, and carbon dioxide levels, and the security team works to find the best route to the event, taking into account stairs, elevators, and badged entries, all in parallel, so that when first responders arrive on the scene, they can be quickly briefed on the situation and do their job as efficiently as possible. Finally, we have everyday occupants. In the event of an emergency, occupants need a tool to quickly report to business owners and operators what the situation is. Meanwhile, operators can push notifications to other occupants that are in an affected space and notify them of proper emergency protocols. This makes sure that first responders know which subjects need treatment and that they have a cleared area of interest in order to perform their job uninterrupted. Currently, owners, operators, and occupants are swimming in a sea of data from numerous systems that makes it nearly impossible to quickly pull together all the necessary information in the rapid, unplanned fashion emergencies demand. Using location as the unifying attribute of this workplace and venue data, we can use ArcGIS Indoors Pro add-in to create indoor maps and maintain connections to databases housing other workplace information, and deliver curated maps to web and mobile apps that allow first responders to access key information they need for situational awareness anywhere at any time. And now I'd like to turn it over to Ian to talk a little bit about what some of these tools already do.
All right, thanks, Bo. So first and foremost, when we talk about event response, there's a lot of content that comes into the situation. So I have spent the greater part of the last 3 years as a solution engineer on the geodesign team here at Esri, and I've really focused on the 3D component, but also the indoor GIS component relating to facilities in the built environment. I've worked with almost every sector at Esri and pretty much every data source available, including BIM. So today, I want to give you a quick run through of some available tools that you can utilize for 3D GIS event planning and response. 3D GIS is becoming ubiquitous across planning and public safety departments throughout the world. Lifelike simulations are imperative for operational safety and security, but also for crisis and disaster response. First and foremost, you'll need data. Miles is going to cover that piece here soon. After you've obtained and refined this 3D data, you can begin utilizing 3D content in a variety of softwares like ArcGIS Pro, City Engine, ArcGIS Online, and ArcGIS Enterprise. So ArcGIS provides a 3D web GIS platform that can improve your dispatch and response. For example, let's go ahead and take a look at this 3D application you see here of San Diego. This application was created with a 3D web scene, our JavaScript API, and ArcGIS Enterprise with the GeoEvent extension. This allows us to bring in real-time data from the 911 system and display in a 3D environment, which allows us to give a realistic view of what is happening across the city. So we can select particular events. In this case, let's select chest pain, and then find a route to the nearest facility, which would be helpful for EMS or first responders. So a pretty quick and simple way to not only find out what the problem is, but to deploy the correct personnel and get this situation taken care of at the nearest hospital. This exact same content can also be used in a web scene to conduct some simple measurements. So in this case, for example, the San Diego Convention Center has multiple events throughout the year. Comic-Con, for example, Esri's International User Conference in July. And the web scene now provides on-the-fly measurement capabilities. So if I needed to gain some insight on simple measurements for, let's say, a traffic barrier, I could do so, but also for building heights. Very simple, easy measurements that we can grab straight from the same data that we used in the prior application. We can even do this for the interior space as well. So just a quick look at how we can establish simple measurements inside the building with height and length, but also outside the building. So once you have this data and you've obtained this data, it can be used in a variety of fashions to help you for dispatch and response, but also event planning and planning for the unplanned event, which is a large part of it. So from here, I want to jump over to ArcGIS Pro and take a look at some of the coolest tools that I've seen in 3D yet. So as a GIS analyst, I get pretty excited whenever someone asks for line of sight analysis or viewshed analysis, because I have all this great 3D content, and this is going to help me plan for a real life event. In this case, let's take a look at our line of sight tools. From here, I can either plan for single placements or multiple placements. And first things first, we're just going to click on the scene to put the observer and the target. And in this case, it's Petco Park. We have baseball games here and other events, and we want to know where we should place our surveillance, whether this is digital or actually real live responder. So in this case, I want to take a look at line of sight for the pitcher's mound, but then I also want to look at some other scenarios. So let's do multiple and just see what line of sight might look like outside of the park as well. There we go. So in this case, even from the top of the building, we can see that they don't actually have true line of sight to the pitcher's mound. So just a quick example. Now we've looked at the outdoor environment. I want to cruise over to the indoor environment and show you what you can do there as well. So let's head back over to the convention center and take a look at creating some simple view sheds inside the building for event planning. We may already have some CCTV cameras placed throughout the facility, but in this case, we want to ensure that all areas are covered. So we can, just as the line of sight tools, we can either do single or multiple placements. We can do a variety of other things as well. So in this case, I want to take a look at view sheds. Let's do an interactive orientation. I can simply click on the map and then use my mouse to determine what angle this camera should be placed. I can do on-the-fly adjustments, as you see here. So I encourage you to play around with these tools. You can adjust the angles, you can adjust the height of the observer, and a variety of other things. One great part about it is that we can use existing features. So let's say I have the cameras already placed throughout the building. I can simply select that layer and then generate some quick view sheds based on the settings here. So make sure that your machine has the correct amount of graphics processing available to work in these 3D environments. The greatest part about these tools is that I can quickly convert those to features as well. In this case, I'm not going to do that because it does take a little bit of time, but just know that your efforts of visual analysis can be converted to actual features also. So you've seen a variety of the tools that you can use in the 3D environment, and a large part of this comes down to that specific content. So remember, it's all about the location when it comes down to preparedness, dispatch, and response. And with that said, I'd like to go ahead and turn it over to Miles to discuss this piece. Miles, the floor is yours.
Thank you, Ian. What we're now going to touch on is how we can enable the collection of this wonderful 3D content. Our businesses are called GroundView and IndoorVU. We're going to step through how to collect outdoor information from an aerial perspective, how to collect ground-based imagery from vehicles and potentially off boats and backpacks and other platforms, and then how to transition and collect data indoors. All of this is about enabling the ability to rapidly collect data, get insight into those environments, and then extract out 3D data to support the wonderful tools that Ian has previously displayed. The vision behind this was to enable a geospatial twin. It is 100% possible today to collect very accurate three-dimensional data at extremely low cost anytime that you want. One of the ways that we've been focused on this is to build very flexible collection systems. So we're going to touch a little bit on the hardware to start with today. The first is a portable pod. we've created a pod that can fit onto the strut of any Cessna that enables us to use local pilots and perform collection using just imagery to reconstruct a 3D environment. You saw some of that previously with Ian displaying the outdoor area around and on top of the San Diego Convention Center. This data is created just purely from photographs. It's reconstructed into 3D point clouds. This is an example of a 3D point cloud of the city of Chicago that was collected from a small fixed-wing aircraft. This is the foundational content that is then used to create the textured meshes to enable the 3D measurements and other capabilities that Ian was displaying before. The second piece I'll touch on is mobile mapping. In the past, this required custom machines, custom vehicles that were kitted out to map the streets. Today, you can use lightweight portable systems like this. All of this packs into the small Pelican case. It can be transported anywhere in the world to do the collection. It can be used around specific events and activities like imaging a parade route before the parade so you have the latest information. Or you can use it to collect the entire city by deploying multiple units. The outputs from this, there are 3 core data sets. The first is enabling you with your own street view. You can now have your own street view inside of ArcGIS that can be as up-to-date as you need it to be. This is done by collection on a single day, and the next following day you can have the same content up and accessible to your teams. What I'm going to show you next is a demonstration of how we leverage this machine and this content around Hurricane Harvey. When Hurricane Harvey was about to make landfall, we decided to go and help out on the response. As part of this, we got involved with the Emergency Operations Center. One of the things that they needed insight into was the current flooding levels that were still occurring after the incident. So we deployed our unit on an airboat and we navigated around the bayou into the suburbs, collecting this information, making it available to the Emergency Operations Center, but then also available to citizens and the public so they could get insight to what was happening with their properties and why they couldn't currently get access back into those locations. As you can see from this imagery, you can assess where the high water mark actually occurred on the buildings, and you can get a lot of insight that is tricky to acquire today through aerial systems and these types of activities. This is what we think of as a gray sky deployment. The second part of the process of creating insightful information out of these mobile mapping systems is to extract 3D points. We're now able to extract 3D points out of the images without using LiDAR and laser scanning. There are new software techniques that we've developed that enable the 3D reconstruction and the ability to extract these points. This data can be extremely rich because we can extract anything that we can visibly see out of the photographs. Any of the data that's extracted then gets constructed into GIS features that are used inside of ArcGIS. So this can be used to map things like street lights and the position of the bulbs. This is very useful if we're trying to determine where to place smart antennas. It can be used to map street signs and other information, other street furniture. You can also use it to collect information during and after events about the flood levels like I'd shown before. I'm just going to switch over and now show you a project that we completed in Brooklyn, New York. This is an example of street level imagery that's collected with extracted GIS features overlaid on top of it. So you can see as we drive through this scene, the different data that's extracted. It's very precise. We get positions on the light bulb, position on the actual height of the light pole, and we're collecting locations of security cameras and hydrants and other assets that the Public Safety Agency is very interested to have mapped. All this data is then overlaid back on top of these images. Okay, once we've extracted that data, we have a raw data set. That data set is then processed and generated into 3D GIS features that support the workflows that Ian demonstrated earlier. One of the other pieces I'd like to touch on here is that out of the photographs that we collect, we can also reconstruct from the ground a textured mesh. This is a three-dimensional mesh structure that is viewed inside of an ArcGIS application, and it has the features we've extracted overlaid on top of it with the labels turned on. This is very similar to the data that is created when you use a drone or a UAS system. However, it's collected from the perspective of the vehicle on the ground. So it gives you some context about the road, the vegetation, and the buildings. It's a very simple system to deploy because it requires less coordination around aviation. You can literally just put this pod on your vehicle and now have your own 3D mesh of all of your streets. Okay, we're just going to transition now to the indoor environment. So as part of our vision to create rapid data in the outdoor space, we identified that folk wanted to transition to the indoor space. So we have a sister business called IndoorVU that, again, is very focused on rapid indoor mapping of the indoor environment in 3 dimensions to enable ArcGIS and ArcGIS Indoors. How does this work? We use different types of scanners. Most of them are mobile scanners, which enable us to scan large areas in a day. We can do up to 500,000 square feet in a day, and we collect really high definition content. So in the middle of the screen here, you'll see a 3D point cloud. This is a laser scan of the interior of the building and the exterior that we collected as we walked around the outside of it. These data sets can be huge. So the next step in the process is to extract them into actionable insights and usable GIS data. So we can create really rapid 2D floor plans, select the 360 imagery, and we can extract 3-dimensional structures in the data like Ian showed earlier on. And as Bo mentioned, we also want to think about integrating other types of sensor data and sensor collection. One of the brilliant things about these mobile mapping systems is that we can integrate other sensors, and you'll see some of this from me later in the presentation. The first step in managing indoor content is to create rapid 2D floor plans. Get this up, make it accessible. We have a portal that lets us manage the portfolio view of multiple buildings, not just a single building. And it lets you navigate to all the different floors and extract the data that you want to view. It also enables us to present the imagery and the 3D content from the indoor environment. So very similar to what I showed you before in the outdoor environment, we have an indoor 360-degree panoramic viewer that gives you the ability to quickly navigate to any space and see the images associated to that space. So in a dispatch scenario, if these indoor spaces are our addressable locations, your dispatchers can access imagery to give them context in helping the response effort. The 3-dimensional data that gets created is also very flexible. In the past, folk creating this from static scanners would focus heavily on always creating very detailed 3D content. This is computer-aided design type of content. Now, because we're so efficient in going through these spaces and in extracting the data, we can create different levels of detail. So we can create a fast output, very simple output, like on the top left of your screen. And then over time, we can improve the quality of the 3D content that we extract. We can do this because we are always collecting the raw high definition point clouds. So this means it's very simple to get going with us to engage and collect data fast. In fact, it almost makes a lot of sense these days to just always be collecting this content and then extracting out the data that you need at the time you need it to start enabling the 3D GIS. So let's touch on another piece of this that Bo mentioned earlier, sensor integration. One of the beautiful things about these machines is that now we can integrate all sorts of different sensors. We've been doing work in the indoor space, specifically around cellular, Wi-Fi, and P25 communication systems. So one of the important pieces that you will always be thinking about is how do you enable communication back to the dispatch system? How do you validate that it's working? How do you understand where there's communication to citizens during an incident? You can now collect data on the performance of the cellular networks inside of these buildings. So you yourself can understand what the communication environment looks like in a GIS and a mapping system. This is all 2-dimensional layers of data, but it's technically 3D because we collect it on every single floor. This can be in the parking garages below the San Diego Convention Center, for example. It can be on the top of the building or in any of the floors throughout the building. And the last point I'd like to make before I hand it over to finish off the presentation is that all of this content is accessible through an API. So it's one thing to collect this content and create it, but you'll have your own computer-aided dispatch systems that are integrating with the GIS. All of the data that we create uses the ArcGIS web services to make accessible the maps and imagery so you can take advantage of it in your applications. With that, I would like to hand over to Brenton Bromley, who's going to conclude the presentation and discuss some of the ways that you can get going with the ArcGIS system for 3D GIS. Brenton.
Thanks, Miles. So before we jump into some of these, this slide right here shows special license for public safety. I have received a few questions during the presentation. I'd like to present those on this webinar. And so I'm going to ask both Miles and Ian and Bo to kind of chime in based on who thinks might be the best person to respond, or maybe it's a collaboration between the three of you. But the first one I received was, what kind of data do people need to get started with 3D and indoors?
Yeah, that's a great question, Brenton. And in an ideal world, a good map or CAD will get you started. But maybe Miles wants to dive a little deeper on this. You can start from scratch as well. As you saw, Miles has the tools to start capturing and creating indoor and outdoor 3D GIS features from scratch, and so it's not outrageous to think that you could be started with this pretty quickly.
Yeah, Bo, I'll just add to that. We can scan with no prior knowledge of a building and create this content. But what's also really important to understand is that we can leverage existing map data or design data, as you referenced, to give us a faster starting point. So often we'll create just updates to the mapping data by using both the design data, the CAD files that may exist. There may be a few years old, or there may be multiple files that represent all sorts of different change outs that have happened to the building structures. And that it just makes us more efficient in extracting data from these point clouds and raw data sets. But as you mentioned, you can also start from fresh, and if you have up-to-date design data on a new build, that can be easily converted into 2D and 3D mapping data to be used in the ArcGIS system.
Mm-hmm. Great, I appreciate that, guys. I do have actually a question that I think it kind of dovetails to this one. And it's really about 3D data that may be already available. So some of the things that you've shown is the creation of 3D data, indoor maps and whatnot. But, is the Esri products and what we are showing is really showing the capabilities of creating new 3D content, or are there options for people to acquire previously generated 3D content?
Yeah, definitely. So that would all be through our ArcGIS online marketplace. We now have that open for partners to be able to deliver existing 3D content through the marketplace to our users.
Okay, great, thank you. The next question is really about hardware. That question is, what hardware will be required to implement ArcGIS Indoors? So a little different, not software now, but talking more of the hardware side.
Yeah, sure, and that makes sense because the challenge with indoor location information has been collecting it accurately. GPS doesn't penetrate buildings, so you need a system that's able to capture that information indoors as well. And for indoors, there's no specific hardware that's needed technically. If you already have Wi-Fi access points and are okay with about 2 to 5 meters of accuracy, then you'd be all set. A lot of folks we've found are interested in getting a little bit more accurate, maybe, and so what they're doing is they're actually looking to augment their existing Wi-Fi access points with a few beacons or LED lights placed in strategic locations in order to provide a more complete coverage of that indoor positioning system. Other than that, you just need a laptop or a kiosk and mobile devices for your occupants and operators in order to kind of continue to collect and explore that information.
Great, thanks. Okay, so let me wrap up with one other question here. And this one is a good one because I know I run into a lot of people asking this question, but the question is simply, is ArcGIS Pro necessary for publishing 3D web scenes?
Yeah, absolutely, Brett. So you will need ArcGIS Pro in order to publish 3D web scenes to either your portal or ArcGIS Online.
Okay, and so that's another nice dovetail. So but I'm going to touch on that ArcGIS Pro here in a second here. But first of all, before I go to that, I just want to say thank you again to Ian, Bo, and Miles for presenting today. That was great content. I really appreciate you doing that. So on the slide right now, you're seeing something about special licensing public safety, and won't go into big details on this slide here, but just want you to be aware of that there are some special pricing and agreements that allow public safety agencies to get their hands on our technology. And it's likely a lot of you on this call have maybe an ELA, a small public safety ELA agreement, or maybe it's tied to a larger city or county enterprise agreement, or maybe a state enterprise agreement. And so depending on what your needs are, it's something that we can talk to you about exactly what's all part of these enterprise agreements. And as you can see, we kind of tailor them to fit all sides. So, whether you're a small agency or a large agency, we try to create a price point that will support you. And then the other thing I think is important to mention is that, when you talk about these events and you talk about response, sometimes you need to spin up a lot more users that are accessing the system, and those are named users. And so we've created some license models around those named users that allow you to work on a shift model, which is very typical in the CAD, 911 space, but also in a surge model, whereas maybe there's a disaster or maybe there's a shooting, and all of a sudden you need to enable a bunch of other responders with the capabilities of your system. So we have created these different pricing models and license models to support you. So the other thing I would want to make people aware of that ArcGIS Pro, we talked about that. And if you are use Esri desktop technology today and current on maintenance, you have ArcGIS Pro. And I've heard a lot of questions about, well, how do we get ArcGIS Pro? What is ArcGIS Pro? So I'd strongly encourage that you work with your account manager, whether it's about any of our licensing and the previous slide or just ArcGIS Pro in general. We want to help you because if you have desktop, you already have ArcGIS Pro. There's nothing more you need to buy. So, and if you don't know who your account manager, please reach out to us. You can see Mike King's email is on this slide, not to pick on Mike, but drop him a note, or you can send us a question, or reach out to us. My email is bbromley@esri.com, and we're happy to get you connected with your account rep to support you on any questions about licensing. And obviously, Mike and I can also support that. A couple things we want to make you aware of coming down the pike here. We have two big events for Esri, our International User Conference, which runs from July 9th through the 13th. And what precedes that is our National Security and Public Safety Summit, which happens on that the Saturday and Sunday. And both of those events are full of great content. Obviously, the National Security Public Safety Summit is all focused on public safety, and we have some great speakers lined up for those events. And then the International User Conference, you'll be able to see a lot more about the information around 3D mapping and 3D content that was presented on the webinar today. So if you're attending, we can absolutely help you navigate the agenda, because there's a lot of different sessions throughout the 5-day conference. Also coming up in the next coming months, we'll have additional webinars like the one you are attending today. So we're still working and finalizing the topics for those, so we will make them aware to everybody in the upcoming weeks and months. Also, FirstNet Hackathon, we've had a couple, I believe. I know we have, but we have another one coming up in Washington, D.C., and we will be sharing, providing more information on that in the upcoming weeks. And lastly, I would say if anybody here happened to be going to the NINA conference in Nashville in a few weeks, or going to APCO or IACP, please reach out to us. Mike King and myself will be at those conferences with some of our other colleagues, and we'd love to spend some time and meet with you and see what you're doing. And if you have any questions or challenges or whatnot, we would love to welcome the opportunity to meet with you. So finally, I want to thank everybody who's joined us for the webinar today. I know your time is precious, and we appreciate you took some time to spend it with us today. So that said, have a great day and take care.